first half of Lab B is a program that you're going to write called Dice or No Dice. So you're just going to submit the dond.cpp file for this section. And this is a pretty straightforward dynamic programming problem. It's not too bad once you get it set up. And it's worth a portion of the grade scripts, and I don't remember how many, probably like 40 or 50 or something like that. Dice or No Dice is worth a certain amount. Spell Path is worth a certain amount, and Spell Seeker is worth a certain amount in part 2. So you're really going to be submitting 3 different programs, but Spell Path is like a base, like a foundation for Spell Seeker. So it's really 2 different problems that you're looking at, but 3 programs you're submitting. All right, so Dice or No Dice is a game show game, apparently. Your friend has come up with a new idea for a game show called Dice or No Dice. So a contestant has a die that is S-sided. You're going to get S on the command line. And the numbers on the die are numbered from 0 to S-1. And you're also given a certain number of times that they must roll that die, and you're going to call that number T. So S is the number of sides on die, and T is number of times you roll. So on each roll after the first, this is important. On each roll after the first, if the contestant rolls a number that equals the previous number or is 1 off of the number they previous rolled, then they lose. So you win if you roll a number and then you roll another number that is more than 1 off of the last one. So getting a 1 and then getting a 4 is a good thing, and then getting a 6 after that is a good thing. Then if you got a 7 next, it's 1 off, so you would lose. If they roll the die T times without losing, they win a certain amount of prize money. So then he throws in an extra twist right here that after each roll, he's going to offer them some money to quit instead. So, and then something about blurry clothes, blah, blah, blah. That's where you come in. And you want to write this program that takes S, T, and last roll on the command line. And he uses the last roll variable in kind of a weird way. It can mean 2 different things. If last roll is -1, then you're going to do something completely different than if last roll is something other than -1. So last roll is -1. Last roll has 2 different functions. Last roll. When it's -1, this means that the program should print the probability of a contestant rolling an S-sided die T times successfully. Print the probability of rolling S-sided die T times successfully. If not -1, look at this sentence. It's going to assume that the contestant has rolled the value in last roll, and we now want the probability of rolling the die T more times successfully. So if it's not -1, then last roll is the, how would we phrase this? The last roll's value is the last not -1, last roll is the last rolled value. Print the probability of rolling T more times successfully. Probability of rolling T more times with an S-sided die. So your 2 cases and 3 command line arguments. So the output should match Dr. Plank's, and he does have error checking, so that means you will need to error check. And his solution had dynamic programming, and it's really not all that bad. So you're going to make sure that you want to read in 4 command line arguments, the program itself, ST and last roll, check to make sure they're integers, and if they are not integers, I think that's when he gives you an error message. He doesn't have an example of what that error is, so you won't see it until you try. But I'm pretty sure he's checking to see that they're all integers, and if not, exit the program. And I would suggest also doing this in a dynamic fashion. So I'll give you a class that might help. Okay, so in your main function, you can read in your arguments and error check. And then I would suggest having a class name it whatever you want. I call it dice. That has a recursive call in it, your cache, and I kept track of S because this is not going to change. So double S, and then your cache. Vector. Vectors. Doubles, because it's keeping track of probabilities. And your recursive call.
Wait, why do we need a vector of vectors for our cache?
I'll explain. You don't have to do it this way. This is how I think about it. But because I have 2 parameters in my recursive call, the cache is a vector of vectors. So when I do this recursive call, the first thing I check for is if I have done this recursive call before. If I have, just look it up in the cache and there's the answer. So the first index, this is a T and this is last. So my cache is going to hold every single time I do a recursive call. And let's say I haven't done that call before, then I'll go ahead and calculate the probability. And I'm going to hold that probability in the cache at my T and my last for whatever particular T and last I have there. So if I end up doing this recursive call twice, then I'm just going to go look it up in the cache and immediately return the answer and not do all my calculations. So that's why I had a vector of doubles. And it's doubles because we're always, whether last roll is -1 or it's not, you want to print the probability of something. Either way, you're printing a probability, and so you're going to want to save a probability as a double. So yeah, the recursive call right here is basically calculating these probabilities, and the first thing you do is check and see if I've called RC with the same parameters before. And if you have, the answer will be in the cache, because every time you calculate an answer, you're going to put it in the cache. So one way to make this pretty easy is when you initialize your cache, just make everything -1. And so that way in this check and see if I've called RC before. Well, if RC at this particular T and this particular last is not equal to -1, then you know you've done that recursive call before. Just return whatever is in the cache at that location. And go ahead and exit out. And then your real base case, let's see. Where's my eraser? Do you see the eraser? I'll just have to move further down. Alright. Okay, so back in RC, the real base case is calculating the probability for just one roll left. And store that in the cache, of course. So having one roll left could be that last roll is -1, or last is 0 if you were given an actual last roll on the parameter. Sorry, this last roll is -1, or what I'm calling last right here is 0. I'll explain what this is in just a second. And otherwise, you're going to do your recursive call. So if you are going to roll multiple times in the future, aka you are in this type of setup, last roll is the last roll valued. You want to see if the probability of succeeding if you roll this number of times with this number of times on the dice. If you're in that kind of situation, then so I'm going to just say that situation is you will roll multiple times. If you're in that type of situation, then the first roll is always going to succeed. So you're kind of just going to forget about that. The way he describes it up here, the first roll, you're just rolling a number, but the only way you win or lose is if you get to a second roll, and the second roll is off by 1 or the same number, then you lose. Or if the second roll is off by 2 or more, then you win, right? So the first roll you can't really win or lose on the first roll. So you're going to say the first roll you always succeed, even though you're not really winning or losing. You're just going to basically forget about it, not worry about it. So the first roll always succeeds, so calculate the probability of the second roll using each side as the last roll. And if you have a last roll, then calculate the probability of success when rolling anything other than the last or last plus or minus 1.